Good evening, sir. This is Team Ravi Teja and Mohit Yadav, and we are going to demonstrate our course project, which is mock blockchain, which is not exactly a blockchain, but it represents the basic functions and the basic structure of a blockchain. So, our project offers a simple simulation of blockchain mechanics to help understand fundamental concepts like block structures, hashing, and mining, like proof of work and blockchain verification. And it is mainly built with Python. So, what are its key features? The first key feature is block generation. Like it shows how a block is generated and how its details are stored, like index, timestamp, data, and the hash of previous block, and also its own unique hash. And also, the feature includes mining via proof of work. Like, what is proof of work? Proof of work requires like the miners who are block creators, like they should solve a difficult mathematical puzzle before they can add a new block to the blockchain, so that like if they succeed in the solving the puzzle, then they can add a new block to the blockchain. And next is the chain verification. It checks the consistency of the chain by verifying block hashes and linkages across the chain. And next is extensible code base. Like our code is easy to modify and expand for additional functionality. And next, like getting started, we need Python to run our code and also pip. And now, like if we see that block structure, each block includes five of its characteristics. And first one is index, like its position in the chain, like 0, 1, 2, 3, 4, and the timestamp, like the time at which the block is created. And next is the data, like the messages or the transactions it is storing. And previous hash, it is the link to the hash. Like in a linked list, we are storing the previous hash of the previous block. And the hash is the unique hash of it of the own block. And next, mining logic or proof of work. To attach a block to the chain, a basic proof of work, like a basic puzzle is to be solved so that we can maintain fairness and security. And next comes the chain integrity. Here, validation ensures that every block properly links to its predecessor by using that previous hash characteristic. And also, hashes are correctly computed using valid block data. Now, let's come into our code base. So, first, Mohit will explain the backend part.
So, all right, let me walk you through this backend code. So here we created a database.py file to store our blockchain in a local folder data, where we are writing and reading blocks from the database py file, where we are storing in data slash blockchain file. So in this, we are also reading last block hash from this database dot using this database.py. Now now we can see our block header.py file. So so this stores all the metadata related to our blocks for in the blockchain. So here we are storing version, that is the version of our block of our protocol, and also previous block hash, and then Merkle root, that is hash of all the transactions in the block, and then time step, at what time step we are creating this block, bits for difficulty, and and nonce for like ensuring our proof of work. It's hard to find the nonce for our problem. So this is our mining algorithm, where we are using SHA hash function, this is our proof of work problem, where we are hashing, like our 4 bits of hash should be 0. So we are looking for that hash function which have 4 0 bits in the starting. Then we can go to the BlockChain, where we define the blocks with the shelf.i, which is the index of the block, and the block size. Also the block header, we are that is metadata, we already defined that, and a transaction count, how many transactions are in that block, and all the list of transactions in that block. Now we can go to our final file, blockchain.py, where we created the whole block, where we created blocks and established. We created blocks and we are connecting them. So here Genesis block is our very first block which we are adding to our blockchain, and after that we are adding other blockchains using add block functions. So in add block functions, so this is our transactions, code is alert send, block height, like which is the right now block height of the position of the block, and Bitcoin store geo. So then we hash all the transaction in that block. Right now we have only one transaction for to get Merkle root hash for that block, and we set our bits to this for difficulty level, and now we can generate our block header. We have version, we have previous block hash which we are getting from the last block, and then we also calculated Merkle root, and we have time step, and we already set our bits. Then we can then we can find block hash using blockheader.mine function, and then we can after that we can save that block to the blockchain. And for creating our chain of blocks, we wrote the main functions where we are looping till we store, and we are creating a block with which has height +1 from the last block, and we are also our transaction is same as, but we are
Yeah, like here, if it is the first block, then it is the Genesis block, and if it is not the first one, then we are extracting the height of the previous block, and then we are taking the previous block and also taking its header and also its hash to create our new block. And then this is the util.py which Mohit mentioned, like the SHA-256. We are using 2 rounds of it for the hashing. And now let's come to the front end part. Like before coming to the front end part, let's come to our example data. Like this is an example data I have taken to show our blockchain. Like what are all these things in a block? Like first one, the height, it's just a position of the block in the blockchain. Like that is the first one, is it the second one, etc. And also the block size, like the number of transactions or the size of the block. Like if you can see here, there is only one transaction, so the block size is one. And also like the transaction also means like the number of transactions. And now let's come to the main part, the block header. Like the block header, and in this first one is version. Like it shows the block version, like it is used to show the rules which are followed. And the next one is previous block hash. This is the main thing which is linking our blockchain, like which is maintaining the chaining part of our blockchain. And next, the Merkle root. This is a hash which is summarizing all transactions in this block. So like in real world, it's calculated by hashing transactions pairwise, a binary tree. Like for every pair, we go up till the root. And then this is the timestamp at which it was created. Yeah. And this is the bits, it is the encoded form of difficulty target. And this is the nonce, a random number like to get a valid hash. And this is the block hash, which is the hash of this block. Like here we can see the block hash of the previous one is the previous block hash of the next block. And now, if we come to the front end, this is just the style. And in the index.html, we can show the blog details on our page. And finally, this is our app.py. So here on this road, we are creating an instance of our blockchain, and then we are also getting the last block, and we are finally showing the last block. And also along with printing, we are also showing it on the Google page. So like on this index.html page, we are giving this block as a property, and like here, all the details of the block are loaded on the page. Thank you.
thank you.